Hello guys, what is up? Welcome to this video. This is Rad Kokadim, and in this video we are going to look at the 2023 Science Paper 1, which is Physics GCE. So if you're watching this video for the first time, make sure that you do subscribe, and so that you don't miss any video or update from us. Okay, so this video is about electricity, and I'll be able to share with you how we can be able to answer this question. Okay, therefore, the question reads, this is a question B8, says, figure B8.1 shows an electric circuit with a 5 ohm resistor R connected to a 12-volt supply. So you can see that this is the question. Okay, so now the first question says, which is A, state Ohm's law. So this is a very straightforward question about Ohm's law. So Ohm's law states that the ratio of voltage to current is a constant. And of course that constant is normally called the resistance. Okay, so that's the Ohm's law. That's what it states. Okay, the second question tells us this to B1, calculate the reading of the instrument labeled A and V. So what are those instruments? So the instrument A is the ammeter, while for V is a voltmeter. So now we have to be able to calculate the reading of that. Now, for the voltmeter, you don't have to actually calculate, because we know that we are measuring voltage across the 5 ohm resistor, which is R. And for that one, all you have to do is that just state that is I think B1. So for V, the readings are just the 12 volts. Okay, and then for the A, okay, which is the ammeter, on this one you have to calculate, which measures the current of the electricity. So therefore, we know that the formula for Ohm's law is just the resistance equals to voltage over the current. So over current. Now, if we make I the subject of the formula by just saying over 1 cross multiply, and then 1 times V is going to be V equals to R times I is just going to be I R. Now from there you can simply divide both sides by R, so that we remain with I. So this goes. Therefore, our I is simply V divided by the resistance. And then from there now, we know from the diagram that our voltage is just 12 volts and our resistance is just 5 ohms. So this is just going to be 12 divided by 5, and this will give us 2.4 amps. Remember, that is the current that we are calculating, and that's the answer. So therefore, Therefore, the instrument A will actually measure 2.4 amps. Okay, that's how you can go about that one. And then for B, okay, so now B is saying what is the cost of using resistor R for 6 hours a day for 30 days if power cost 15 ingwe per kilowatt hour or per unit? Now, I want you to pay attention to this question. So we are going to move in about 4 steps. So the first step is, so this is a B2. So we are going to move in a 4 step that I'm going to call first step, which is A. So find the total hours. Okay, the total hours for 30 days. 30 days. And then from there now, we are going to say, we know that per hour it is 6 hours. So the total hours is just going to be 6 hours multiplied by 30, which is our total days, and that will give you 180 hours. Okay. And then from there, the second step is convert. Find the power. Find the power. Okay. Find the power. So the formula for finding the power in terms of our current is power equals to current times voltage. So we know that the current we have found it is 2.4, and the voltage is just 12 volts. Therefore, replacing these numbers, we are going to get 2.4 multiplied by 12, and this is just going to be 28.8. The units of power are watts or just watts. Then from there now, under that one, convert the power to kilowatts. So we know that 1 kilowatts equals to 1,000 watts. Okay. Now, what about 28.8 watts? So we are converting that from watts to kilowatts. So pay attention to that, and this is going to be you cross multiply. So we are going to have x times 1,000. We are going to get 1,000x, and then 1 multiplied by 28.8. We are going to get 28.8. So therefore, we are going to have 1,000 x equals to 28.8. Then we are going to divide both sides by 1,000. Divide both sides by 1,000, and this goes. So our x is going to be 0.0288 kilowatts. Now, after that, you now need to find the energy. How much energy has been used for 180 watts? So our third step is find the energy used for 180 hours. Okay, 180 hours. So what's the formula for energy? So the formula for energy, or rather, equals to power. Okay, power in terms of energy is just going to be power equals to E for energy over the time. Okay, now we know that we are looking for the energy, so we make E the subject of the formula, and this is going to be E equals to, then P times T. This will just be PT. And from there now, so the energy equals to the power multiplied by time. Now we know that the power was found to be 0.0288. Okay, and the time, the total time is 180 hours. So just a matter of replacing now. The energy is equal to 0.0288 multiplied by the time, 180. So this will give you the total energy is 5.184 kilowatts hour, because this is in kilowatt, this is in hour. Sometimes this is just called units. Okay, so that's how you can find the energy. Now after you find the energy, okay, then the last step now, which is D, finally find the cost. Find the cost for using these units. Now what are these units? Just 5.184 kilowatts hour. Okay, so we have been told in the question, okay, that the cost of 1 kilowatts hour, which is the unit, is just 15 ngwe. Okay, you can see there 15 ngwe. So what about using 5.184? So this is just saying that 1 unit is costing 15 ngwe. Okay, now what about 5.184? Okay, 5.14 units will be able to cost how much? So just a simple proportion, cross multiply, and this will give you 1 times x, just x, and then this times that, so 5.184 multiplied by 15, then our x is just going to be, our x equals to 77.78 kwacha. So this is just 77.78 ngwe. So 77 kwacha, 78 ngwe. So that's how you can go about solving this question. Thank you so much. This is Professor Waramike, and this is Wadco Academy. Thanks for watching. Share and like. Subscribe to our channel for more information. Thank you so much.